Hi, this is Zoe from Seneca, and today we're going to look at balancing equations. So, balanced equations are absolutely crucial to any kind of quantitative chemistry. So listen up. Right, so, first of all, let's start with, what are they? Because that is a good place to start. There are a few key features of balanced equations. They must have an equal number of atoms on either side. You add more atoms by adding reactants or products to either side. And there's no method to do this apart from trial and error. Just find out what works. Balanced equations are useful because they can be used to calculate masses of reactants and volumes of gas. We'll demonstrate these in some worked examples that we'll do in this episode. Titration is an experimental technique for finding the concentrations of solutions. Titrations use balanced equations to calculate the concentration of an unknown solution from a volume of a known solution. The experimental technique involves the use of a burette and often an indicator. A small volume of solution is dropped from the burette into the reaction flask. This is repeated until the indicator shows no further reaction happening. Okay, so here's a worked example. What volume of steam will react with 24 litres of ethene according to the balanced equation shown? So the balanced equation is C2H4 plus H2O goes to C2H5OH. So first of all, find the ratio of ethene to steam. The balanced equation shows 1 mole of ethene reacts with 1 mole of steam. C2H4 plus H2O. Then use the ratio to find the volume of steam required. 24 litres of ethene requires 24 litres of steam. Okay, easy enough. What volume of hydrogen gas will react with 2 litres of chlorine gas given that the reactant ratio is 1:1? 2 litres. Okay. Ionic equations are used to describe reactions in solution. Ionic solids will dissolve in solution and will split into their constituent ions. For example, NaCl will go to Na plus aqueous and Cl minus aqueous. Some of the ions dissolved in the solution will react in solution, but some of the ions dissolved will not be involved in any reaction. These ions are called spectator ions, right? Spectator ions. Ionic equations are equations that have included all the non-reacting spectator ions. The charge on either side of the ionic equation should be equal. So complete the generic ionic equation for the dissolving of ionic solids in solution. Mx aqueous, and then this reversible arrow, goes to M plus aqueous and X minus aqueous. State symbols are letters that tell us whether what state of matter a substance is in. There are 4 different state symbols. These include S, which is used for solids, for example, magnesium S solid or sodium S solid. L is used for pure liquids, for example, H2O liquid and Hg liquid, which is mercury when it's at room temperature, is also a liquid. Aqueous, Aq, is used for aqueous solutions, which is substances dissolved in water, and therefore it is used more often than L, liquid. Okay, for example, NaOH, which is aqueous, and H2SO4, also aqueous. G, small g, is used for gases, for example, H2 gas and CO2 gas. State symbols are useful to chemists because the state a reactant is produced in can affect experimental techniques. For example, you wouldn't want to carry out a reaction that generates 30 moles of CO2 in a 10 centimetre cubed sealed vessel. It would explode. We don't want that. If you left your state symbols out, you might try this. And that wouldn't be great because you'd have an explosion on your hands. What do we call the letters that tell us the state of matter of substances in a chemical reaction or chemical equation? And the answer is state symbols. Okay, let's do this worked example. What mass of water will react with 7.99 grams of bromine? The equation is Br2 plus H2O goes to BrOH and HBr. So calculate the moles of bromine. So we're going to do 7.99 grams divided by 79.9 equals 0.1 moles. Then use the balanced equation to find out the moles of water. It's a 1-to-1 ratio, so there are also 0.1 moles of water. Remember the equation for calculating mass, which is mass equals moles times mR. And then we can calculate the mass of water. So 0.1 moles times by 18 equals 1.8 grams. Phew, nice video there. Okay, that's all for today. Thank you very much for joining, and we'll see you on the next episode. Bye.